What is up, guys? Today we are going to build a report in Power BI featuring Pokémon. The report will have a page for each Pokémon primary type and all the evolutions associated. So it will include all 1215 Pokémons with the special variations like Alolan, Galarian, Mega and so on. The video is divided into sections, so feel free to skip to a section if you want to see how specific part of the report was built. So without further ado, let's get into it. Okay, so here we are in Figma. The first part of the report is to sketch out the layout of the report, so the design part. So first we are going to start by building a background which has the measures of the report page. And then after that is done, we can start to draw the initial sketch, the layout of the report. So here we have the first box, which is going to include a chart, plot chart for the primary and secondary evolution types. The part above will include a filter to switch between the primary types, and then the part on the top will include the actual filter for the Pokémons. So once that's done, we will switch to the main section, which will include the main images of each evolution and also the stats for the different attributes the Pokémon have. The top part has the title, which is the type, and here we draw the place for the evolutions. This box is going to feature the description for each Pokémon, so you can switch between the description between each Pokémon. And finally, the stats, the attribute bars, will display each given attribute the Pokémon have. Okay, so the next part we are going to duplicate the sketch layout so that we will have something to use as a reference for the actual page. So here I'm just duplicating the sketch, and now I'm opening the Copilot in order to create the background for the first type, which is going to be the fire type. So I'm just going to ask Copilot to generate a fire type Pokemon background to get a random background that we can then use for the sketch. So it returns this kind of art. I think that looks pretty nice, so we're going to use that for the first type. So now we can start to build the actual parts of the report. So the first part is going to be the type part. So it's just a square with a little bit of gradient added into it and a little bit of reflection for a nice looking lightning effect. Rounded edges, and finally adding some small touch with the shadow. After that's done, we can just duplicate it and use that as the frame for all the other parts of the report. Here you can just use the same square and change it to be according to the sketch frame. Now we are going to create the font for the titles. Here we are going to use the Showcard Gothic font, because that's the closest to the Pokémon font I found that Figma has in vanilla version. So here we just give it an initial color, and we have the first type title. After that we can take the AI art Copilot created and we can add it as a background for the report frame. Okay, looks pretty nice. After that we can just group everything together and rename it as a fire. So then we can duplicate the square once more to use it as a layer for the description box, which will include all the descriptions, and also for the attribute stat boxes. Adding the same reflection for those boxes. And that is done. Finally, adding some shadows to the boxes and duplicating the page for the second type. But before we go to the second type, we need to add the type icon. So I'm here just googling different type icons that are available, and I found a pretty nice one with a black and white background. So just remove the background, and then we can duplicate the type and crop out the specific type that we want, and we can just replicate this process for each type. So here we have the fire type. Can add it to the sketch and use the overlay or the soft light for a nice see-through effect. So here I'm creating the type and the Pokémon filter titles. So the first one is going to be the Pokémon, and the type. And here we have the evolutions. So here I just decided to put evolution 1, 2 and 3 next to each other for a clear look. Okay, after that is done, I wanted to show one additional way to create the report background if you want to spend some extra effort. Here I created a background with the same Copilot by asking it to create a random background, and then I use the Pokémon images that we have with the dataset, and I take a Pokémon, here the Scarlet, and I'm just placing it on the AI generated background to create a little bit more Pokémon-ish effect. Let's save that to the images folder, and now we can use it for the second type, which is the grass type, as background. So next I'm just duplicating the page for the second type, which is going to be the grass type. So here I'm creating the title and just basically switching the colors with the same exact boxes that we already created for the first sketch. So here just switching the colors by multi-selecting, and then from the right pane, from the selection colors, just changing everything to the same color first. Now I added the background that we just created, and finally changing the font color to something that is a little bit easier to observe. Exporting to the images, and then also changing the fire type font. It's a little bit clearer. So next I duplicated all the pages and created this custom page for the tooltip that we can then use for the Pokemon attributes. So once we create those, we have this page ready. It's just the same square with the same design and the type icon. And here we have skipped where all the backgrounds for all the 18 types are ready. So everything is created with the same principle with the Copilot background, and just adding a custom colors based on the original sketch that we have. Okay, so finally we can go ahead and create the main page that is going to be the landing page for the report. So here I'm just removing all the unnecessary squares that we created and the titles, and just keep the type and the Pokemon filter boxes so that we can use those. And I'm changing the design a little bit by adding a custom gradient for the rainbow colors that represent all the different Pokemon types. And then I'm just duplicating this design also for the Pokemon filter. And now we're going to add the main Pokemon title for the report. We just has the title with background removed. And now I'm selecting the color for the, so basically using the pick color from the left pane, and then taking that color and using it for the type and the Pokemon filter titles. Picking the blue color, using that as the stroke value. Now copying that to the Pokemon filter, and here the Pokemon E has the top dot. I just went ahead to another website and copied that. And the background is also created with the Copilot. Now renaming it as main and exporting everything. So now all the type backgrounds and the tooltip backgrounds are ready. So finally we have to create the type filter icons. So here I imported another type sheet that we can use, and I'm using the exactly same process we already used for the black and white background. So using the same process for all the 18 primary elements, and then we can use those as our filter icons. Renaming the files, and here all the icons are ready for exporting. For the storage of all the type icons, we are going to use OneDrive, and here I'm the OneDrive. I have created a Pokemon folder and a types folder for all the type icons, and I just imported all the files from Figma in here. You can just upload them from the file upload. Now the next step is going to be embedding each icon so that they can be used in Power BI. So here I choose embed, I choose the original size, and then OneDrive will give you the embedded link so you can use it inside Power BI. Okay, so here we are in Power BI. First I'm going to open the Power Query, and I'm going to duplicate the type column. After that I'm going to split it with the delimiter of comma, and then renaming the first part as primary and the second part as secondary type, so that we end up with primary and secondary types. Have to remember to change the name also in the split step. And here I'm adding the primary type as a new query, changing it to table, and then removing the duplicates to end up with all the 18 types. Then I'm going to copy it and import it into Excel so we can start to create our type color and type icon list. So here I created column type icon, and now I'm just going to embed all the type icons from OneDrive and copy and paste them into our type icon list. So now, once all the type icons are imported to the sheet, we can go ahead and create the color column. And here I'm just going to Figma and using the same color that we already used for the Figma titles. Once those are ready, we can go back to Power BI and start creating the type filter. Here I'm using the new filter visual and I'm adding the type column to the field. I'm changing the layout to display only one column and 3 rows and removing the blanks. First, we have to change the data category to image URL, and then we can add the type icon to the image field. The URLs load depending on your internet connection. After that's done, we can start to create the text color measure. So here I'm using a switch. So if the Pokémon or the type is filtered, then we select from the types with switch and add the color. Here I'm just copying the values for easy inputting. So here with Alt and clicking, I'm just selecting all the text words with one click, so it's faster to add all the semicolons. And else statement is just the color type based on the selected type. So here I go to the filter values, and in the conditional format field I select field value and input the text color measure. So it will import all the colors based on the type. Now, just in case I went into the modeling section, sometimes Power BI automatically creates relationships, so I deleted those and redid the relationships between the tables. So here we can create a relationship between our main Pokémon database table and the type based on the primary type. It's one-to-many. Here I changed the cross-filter direction to both, and now we are ready to start building the background. For the background we are going to use the image storage method of converting the image file to binary 64 and then using that converted text in the report. So basically it will split a large image into multiple rows of text, and then with a DAX measure we can combine those back together and use them in the report. The method is presented by Chris Webb in his blog, and I will include the link to this blog in the description, so you can go and check it out. So here we can open the Power Query and we can create a new blank query. And now when we go to the advanced editor, we can just paste the code from Chris Webb's blog. So what we need to do, we only have to change the source folder to our image folder, and once that's changed, we can just press done and we're ready to go. So here we have the backgrounds. I just duplicated the name and then renamed it and changed the name so that the PNG is removed, so we end up only with the name of the type. Renaming the query to background and pressing apply. Now we have to import the background, so we're using the HTML custom visual. You can get it from the app source. Just add it to the report if you don't have it already. Now we can start building the measure which combines the rows that we changed to text as binary 64. So here if has one value, the name of the image, then we do a beginning data image PNG base 64 as a HTML, and we concatenate and combine that with the different parts, rows of the text the image is converted to. Let's change that data category to image URL, and now we can build another measure, which is the actual background with the if condition. Let's create variable background and we check if type or the Pokémon is filtered. Then we call the background image based on the type that is filtered. Else we can choose the icon main, which is the landing page for the report. Here we have to include the HTML image source, and then we need to define the height and width of the image. So we are going to use the report background height and width. Now we are ready, we can try if the background works. Let's add it to the HTML visual, and the background seems to work. If you choose the type, it will change the background accordingly. One small adjustment, we have to go back to the background measure and change width and height each by 10 pixels so that the background image fits accordingly. Now we can align the type filters. And we can start to build the Pokémon filter. So here I'm in the images folder where we have all our Pokémon images. Here we can use the -kind :folder ..new to get all the images that already have a transparent background. So we don't have to manually edit them. So we can just copy everything from here and then create a new folder. Call it Pokémon and then can paste everything here. So once the images are pasted, now we can go to the Power Rename app and then to the top left search bar we can type _new so that we can remove all text where it says new. So we end up with only the Pokemon's name in the image. Now the idea is to create another duplicate of this image folder in order to use as the filter icons, because there is so many it might give some problems with the image size. So we can use the image resizer tool to resize the images. So we can use the custom layout, and 70 × 90 pixels is a pretty good size and greatly reduces the image size. So now we have two image folders, one that we can use for the evolutions and one for the Pokémon filter with reduced size. Next, the idea is to import all the small images to the same folder where the big large images are, so we can use only one data table. So I'm going to the Power Rename once more, and I'm going to select .png, and then I'm going to replace that with as.png to get as in the ending of every Pokémon name. Pressing apply, and now we can copy, cut and paste everything to the folder with the large images and delete the small images folder. Next we can go to the Power Query and we can go to the background table, advanced editor, and copy the code from there. We can create a new blank query and then paste the code and change the file path to our Pokémon image folder. Now you can see the small images and the large images, and the large images have more rows than the smaller one because of the size. Renaming to Pokémon and then hitting apply. Now we have to create the measure which concatenates the image rows. So we can just duplicate the background image measure, paste it and change the background to Pokémon. Otherwise it's the same. Changing the data category to image URL once more. And now we can create the image measure. So here we just calculate the Pokémon image that we just created and filtering it by the currently selected Pokémon. So here we put the icon from the Pokémon image table and then selected Pokémon. Changing that to image URL as well. And now we can duplicate the type filter. We can change the values to Pokémon. We can change the filter to a table and then input our Pokémon images as the first column of the table. Now, changing the table type, removing background, and in the cell specific columns, cell elements, you can choose Pokémon, and then from the font color, conditional format, field value, and we can input the text color. So now it has the same dynamic text and the type filter. Next we can go to the values, increase the font size, align the filter, and you can rename the columns with space character to get rid of the titles. In the type filter we can do the same, remove the background. From the values, increase the font. And now when you select a Pokémon or a type, the background changes accordingly. Next we can start to build the chart plot to accompany the type filter. So here we can go to the custom visuals from App Source and select the chart from Microsoft, add it to the report and place it under the type filter. Now we can go and find our primary type and put it to the from field and the secondary type to the to field. We can go and select the Pokémon and select count of Pokémon as our value, and then we can remove the background and all the text, title, axis and labels for a cleaner look. Now you can see our types, so we can go and first remove the blanks from the filter. Then we have all the type colors, so we can go to our type Excel file and select all the type colors. This is a little bit manual process, I will skip to the end, but you will just have to change the colors one by one. Once the colors are ready, we can go ahead and do final adjustments to the plot, make it a little bit larger. And now when we select a type or a Pokémon, it will filter the primary and all the respective secondary types that are available for the selected type or selected Pokémon. And now we're ready with our filters. So next we can start to build our evolutions. By default, our dataset doesn't come with any evolution columns or identifications. So I'm going to the Pokémon API and I'm going to the documentation, and then you can search for the evolution, Control F, and we can find the PokeAPI evolution chain. So we are going to use this API to get the Pokemon evolutions and then integrate those into our existing Pokemon table. So here you can see one search result for the API evolution chain, just input it into a browser. So this is the call we are also going to use in Power BI. So we are going to select the web connector and then paste that same API URL, then hit OK. And now we can see the API call result as a table form. So here we can rename the query to function fn evolution. So now we can start to expand the result columns. So first we can expand the chain evolves to. We can expand everything, and from the result we can go to the species column and then expand the name. So we get the second evolution. Next we can go to the evolves to, expand that list to records, and then from the evolves to record we can expand species again, and from the species we can expand the name to get the third evolution, Venusaur. The first evolution, Bulbasaur, we can rename it as evolution 1. Then the second evolution, Ivysaur, we can name that to evolution 2. And the third, Venusaur, as evolution 3. Finally, we can remove the unnecessary columns. And we are left with the evolutions and ID. Next, we can go ahead and create a new parameter. So right click, new parameter, and then change the parameter name as evolution ID, and then replacing the type as text and setting the current value as 1, which is the evolution for Venusaur, Ivysaur and Bulbasaur. Then we can go to advanced editor and change the evolution chain ID section. So the query parameter, we can input our evolution ID parameter with double quotes and AND signs. Now when you click done, you can see that we get the same result as we did before for the first evolution. Next, we can group the functions in a new group, so move to new group. We can call the group fn evolutions, and then we can disable the report refresh and disable the report load. Now we can create a new blank query, and we can call function list.generate, then brackets. Function, we call it 549 times, each underscore is equals more than 0. Then each underscore minus 1. So we get a list of values from 1 until 549. Then we can convert the list to a table, and we can sort the table in ascending order starting from 1. Now we can change the type to text, and then we can go to add column, invoke custom function, and we can use the fn evolutions as the function query and the column 1 as the evolution ID. Hit OK. Now we can go and remove errors in case there are any, and then we can expand the evolutions. Once the evolutions are expanded, we can change the type as text. Then we can rename the query as evolutions. And we can remove the first ID column. Now we can hit apply. We can wait the API to load. Once that's ready, we can go back to the report. And we can go to our evolutions table. We can copy the table. Now we can go to a blank Excel file and we can paste the table here. We can Ctrl T, transform it as table. Then we can save it as evolution. Now we can go back to Power Query and import the evolution Excel. Then we can disable the refresh and disable the load from the evolutions API table and move it to the F1 evolution group. We can rename the evolution query as evolution. We can change the type to text. And then we can go to transform and capitalize each word. Now we can go back to the main Pokémon table and we can do a merge. We can choose our evolution table and select the first evolution. Then we select the Pokémon-copy from the main table and we do a left outer join. Now we can expand all three evolutions. We can rename the evolutions as first evolution 1, second evolution 1 and third evolution 1, as these are the evolutions merged based on the first evolution. Then we can do another merge. This time we can use the evolution 2 column from the evolution table and we can use the Pokémon-copy from the main table. We can expand the evolutions and rename them as first evolution 2, second evolution 2 and third evolution 2. Now we can do third merge for the third evolution. Expand the evolutions and rename as first evolution 3, second evolution 3 and for third evolution 3. Now the evolutions are ready except the first one. So the first evolution 1 is a little bit trickier because of the special types like Mega, Iron and so on. So how we can get over this is we can go to our Pokémon-copy column. We can add the column as a new query. Then we can convert it to a table. We can do a new merge. And we can select the second evolution from the evolution table. Left outer join. We can expand the evolution 2 column. And then we can do the same for the third evolution from the evolution table. Left outer join, hit OK, and expand only the third evolution. Now we can select the evolution 2 and evolution 3 columns and go to transform and pivot columns. Next we have to create a new list, so we can go to the column 1 and add that as a new query. Now we can change it to table. Next we can do a merge. We can merge it with our Pokémon-copy table and we can choose the value column from the Pokémon-copy table. Then we can expand only the value. And now we can sort the column, so we can unselect everything except the null. So we are left with only the first evolution. Now we can rename the column as first evolution and move it to the first evolution 1 place. Now we can rename the column as first evolution. After that we can delete the unnecessary tables. We can do enter data. Then we can paste the values from the column to the enter data. We can rename the new table as first evolution, and then we can go back to the main Pokémon table. From the first evolution, as we're using it in the merge, we can just disable the load and refresh. And now we can expand the first evolution. We can rename the column as first evolution. We can move the column where we have our original first evolution column, and we can remove the first evolution 1 column as we don't need it anymore. We can rename the first evolution as first evolution 1. So we are left with our first evolution including the special variations. Next we can go and remove the unnecessary tables. So we can go to column 1 and remove that, and we can remove the Pokemon-copy table, and we can disable the refresh and disable the load from the evolution Excel table and move that to the F1 evolutions on top. We can also do the same for the first evolution, so remove the refresh and load and move that as well. After the evolutions are ready, sometimes when we merge queries there might be duplicate values in the data. So how we can avoid this is that we can go to the main Pokemon column and we can remove duplicates to get the correct amount. Now we can hit apply and our evolutions are ready. Now, once back in the report, we can go and start creating the evolutions measure. So here first we do a simple selected value Pokemon. Then we can create a second variable called Pokemon name. So here we choose if the first evolution from the filter table is filtered and the first evolution and the currently selected Pokemon are contained in the same row of the main Pokemon table. So if that is true, then we calculate the first evolution 1 where the Pokemon is the currently selected Pokemon. Now we can duplicate this and change the filter table to evolution 2 and also change the selected value in the calculate as second evolution 1. Then we can duplicate it once more, change it to evolution 3 from the filter table and choose the third evolution 1 for the calculate selected value. So basically we check if the currently selected Pokemon from the Pokemon filter is found in the same row as the second evolution, third evolution or first evolution. If that's true, so if they are in the same row, then we can return all the evolutions that are found in that same row. So this is what the contains function does. Otherwise we will return blank. So if there is a Pokemon and it has second evolution, it will show 2 evolutions in the report and not the third evolution. So third evolution is blank. Moving on with the measure, we can duplicate all 3 filtered evolutions and change the contains function to include the second evolution too. So here we check if the second evolution 2 Pokemon and the currently selected Pokémon are contained in the same row of the Pokémon table. If that's true, then we do the same calculate, but this time we use the second evolution. So first evolution 2, then second evolution 2, and finally third evolution 2 in the calculate function. Now we can duplicate it once more and do the exactly same process for the third evolution. So in the contains function we put third evolution 3. We duplicate this, and then in the calculate function we display first evolution 3, second evolution 3, and third evolution 3. After that we can create another variable for the Pokémon image. So here we can just copy the Pokémon name and change it slightly to include the image. So in the place of the evolution we can place our Pokémon image measure, where the icon from the Pokémon image table is the Pokémon name from the variable Pokémon name. Otherwise the contains and the filter conditions are the same. Now we can just duplicate this to all the measure blocks, and after that the Pokémon image variable is ready. Now we can create the third variable, and this is for the animation. So it will be mainly CSS styling and also HTML to display the measure. The idea for this animation comes from Jefferson. I will include his video instruction in the description below. So first we create a style parameter, then in the style we create .card, and then position is relative, then width we place 100 VV, and height we place also 100 VWV. Then we place display, that is flex. Then justify dash content, that's in the center. After that we do align items, also in the center, and overflow. For the overflowing image we display hidden, so there is no overflow. Now we can do an end style to end the CSS style block. And next we can call the .card style block with a div class equals card. Now we can create our second style block, which is the .loader. So here we put position equals absolute, width is 95%, height is also 95%, the background, here we actually could choose the same color as the type, but here we want to put a transparent background instead, so we can change the background to the color code EAE BEC, which is the color for transparent. Then we select the border radius, which is 50%, And now we can go ahead and call the loader style block with the div class equals loader, and then end divide. Now just one addition to the loader style block, we can add the animation, which is the animation colon girar 7 seconds infinite linear. So what this means is the animation takes 7 seconds to complete and it's infinity, so it doesn't stop, and the linear means that it also continues as a continuous cycle instead of starting over every 7 seconds. Next we can create our third style block, which is .progressive-border. So here we also select position absolute, width is 50%, height is 100%. Then we can select the background, which is a linear gradient, so we get a gradient, and here we can input our text color to get the color based on the selected type with a gradient. And the gradient second color is transparent. And here we can display border top left radius 100 VV and border bottom left radius 100 VV to get a semi half circle. Next we can call our third style block, so div class progressive border and end div. So here you can see the semi half circle with the gradient color that disappears on the other side of the circle. Next we can create our fourth style block, which is the .background_photo. So here position is absolute, inset is 5 VW. The background, here we can input the background color, which is going to be the same color as the type. So measure text color. Then the border radius, we use 50%, and we can call with the div class the background_photo, end divide. Moving on, we can create our fifth style block, which is the .photo, to display the Pokémon image. So here position is absolute, width is 80 VW, height 80 VW, and border radius is 50%. And the last property is the object fit, which is optional. So here you can place for example contain if you want to shrink the image, or scale dash down, or fill to fill the image in the given borders. But here we leave it empty. So after that we can go ahead and call the image class equals photo src, and then in the and signs we can put our Pokemon image variable to display the image. End div. Here you can see our evolutions displaying in the report. To end the style block we can include the actual animation, so we input the and keyframes animation rule, and then we name it girar so that we can reference the girar animation from the loader property. So and keyframes girar from transform rotate, which is 0 degrees. We go to transform rotate and 720 degrees, so there's 2 full circles of animation. So here you can see the animation working with the different Pokemon selected. Moving on, now we can create the Pokemon name, which displays under the animation. So here we can go back to the style block and add a value block. So here the color is the color based on type, text color. The font size is 18 pixels. The font dash family is D-din, sans dash sheriff. Here, between the two last end divs, we can call the value class, which is the text, and in the variable Pokemon name. You can end it with end value, and now you can see the name appearing below the animation. Here we added B to get the text in bold. Now we can return the above variables with the if condition. So if the evolution 1 table is filtered and the Pokemon name is not blank, then we return the animation, and we repeat this for if the evolution 2 from the filtered table is filtered, or the evolution 3 from the filtered table is filtered. Otherwise we return blank, like you can see here in the case of Swablu and Altaria. So next we can start to create our descriptions, which will display under the evolution. So first we can open up the Power Query and we can duplicate the main Pokemon column, add as a new query, and then we can convert to table. And let's create a column from the example from selection, and we can just choose the first Pokemon and add a comma. Now all the Pokemons have a comma after the name, and hit apply. The reason for this column is that it's easier for the AI to generate answers when the names are separated by comma separator. Now we can go to that table that we just created and copy it. Let's import the copied table to Excel file. This is going to be our descriptions Excel. So now transforming it to a table with Ctrl T, changing the color, and ordering from A to Z, so that we get all the A's first. Now we can copy the names, we can go to the AI, we can write a prompt, write a summary of each Pokemon below, then adding all the Pokemon names separated by comma, with 300 characters each, and add a Pokédex number. So now the GPT is generating answers. The reason why I'm only adding 29 names to the prompt is that sometimes when it is generating answers, the RAM memory gets full, and then the site will crash and you will have to reload the site to create another prompt. You can get over this by using some paid GPT, such as OpenAI, with a subscription, but here I'm using the Talk AI because it's a free way of doing it. So next we can go to our descriptions Excel file. We can rename the sheet as description. Here I'm deleting the sheet 1 as it's unnecessary. Then we can add a column called description. We can go back to the prompt result. Now you can see all the results have the Pokemon name, Pokédex number, and the description. Copy the values. Now we can go back to our description Excel. Remember to sort the Pokemons from A to Z and paste them into the description column. Now when we have the descriptions, we can go to the data field, add data from the table, and now let's split the column by delimiter, custom delimiter, then we use dot space to get rid of the number, then we split the column again, custom delimiter, space square bracket to get rid of the name, then once more we split the column by custom delimiter, this time square bracket colon to get rid of the Pokédex ID, and we are left with the description column. So now we can rename the columns. So let's rename this description, this Pokédex ID, and here we can just put name. We can remove the number field and load them to the Excel sheet. Now we have our Pokédex ID and description columns, so we can delete the unnecessary merged column with dot, with comma, and also the name column. So we're left only with identifier Pokémon, Pokédex ID, and the description. So our description Excel file is ready. So back in the report we can go to Power Query, we can import our description Excel file. Now we have to choose the right table, so in this case it's the sheet 3 that has the transformations. Hit OK. We can use the first row as headers. If it's not done automatically, change the name of the table to description, and we can apply. Now our description table is ready for use. Next we can create the description, so we can add the HTML visual to the description box below the animations. Now we can go and create the description measure. So the measure uses mainly the similar logic than the Pokémon name variable from the evolutions measure, so we can copy that. Then we can paste it to the new measure, call it description, and we can rename the variable description. Now we need to change the measure logic. So where the first evolution is currently in the calculate expression as the selected value, we can copy that, cut it, and move it into the filter condition selected value. Now we need to duplicate this to all the evolutions. Copy it from calculate expression to the filter condition. Once that's ready, now we can add the calculate expression, so we can insert the description from the description table as the selected value. Now we can duplicate this to all the evolutions. And finally, we can change the filter condition, so we can change the main Pokémon table to the description table. So the Pokémon from the description table equals the selected evolution. Now the description variable is ready and we can return it. Here we can create another CSS style sheet. Here we can insert a new style block value, and we can add property font size is 18 pixels. Font family equals d-din, comma sans serif, so the same as the description. And then we can add the property color, which is the dynamic text color measure based on the selected type. Now we can do end style. And then we can call the value with value class equals text. We can add B for bold text. And then we can add our description variable. End value. And we can add the end B. Now the description measure is ready and we can add it to the HTML visual. Now we can add the evolution from the filter table as the description filter. Then we can remove the background. We can align it to fit into the box properly. And then we can go to the default body styling, text alignment, align to the middle. Now we can duplicate the description box for the second and third evolution. Then we can go to the second description and we can add the evolution 2 from the filter table. Same for the third evolution. We can just add that it is not blank to filter it. We can just add evolution 3 is not blank to filter it. Now we can rename the description box as description 1, 2 and 3. Then we can create bookmarks. We can call them evolution 1, 2 and 3. We can remove the data from the bookmarks and add that the filter affects only selected visuals. Now we can hide the second and third description, group them together and call the group evolutions. We can update the first evolution bookmark and now we can duplicate it for the second and third description. Now we have to create the buttons for the bookmarks. So we can go and add a button, then a blank button and add it on top of the evolution. Now we can align the button and remove the icon and border. We can set the action on and then type bookmark and then select the evolution 1 for Swablu. Now we can duplicate it for the second evolution. Align the book, align the button, and finally duplicate it for the third evolution. Set the evolution tree as bookmark, and now we can change between the evolutions and the description changes accordingly. Now you can see that the description and the Pokemon name text is slightly different than the text in the Pokemon filter and type filter. So there was an error in the description CSS style sheet. The font family should be sans serif and not sans sheriff with an H. So after that is corrected, we can also go to the Pokemon evolutions and do the same correction. Changing the sans sheriff to sans serif without H. And now the font looks correct. Now we can start creating the attribute bars for the different Pokemons. So first we can go to our main Pokemon table and we can add the main Pokemon column as a new query. Then we can remove the last step, Pokemon 1, to get all the columns visible. Now we can go and select all the attributes such as height, weight, catch rate, base friendship, base experience, hit point base, attack base, defense base, special attack base, special defense base, and the speed base. Now we can go to the remove columns and remove other columns, so that we only left with the Pokemon column and all the attribute columns. Then we can select all the attribute columns and select unpivot columns from the transform. Now we get all the attributes as the attribute and all the values as the value. So now we can clean the value column by splitting it with a delimiter of square bracket, so that we are only left with the metric, meter and kilogram. So next we can go and duplicate the value column, and then we can split the column by delimiter of space to remove the kilogram and metric, so that we end up with a pure value column, which we can then use as the attribute bar length in the measure. Now I removed the unnecessary column with the formats. I went back to the previous step and renamed the value column as a value. Now I create a new column from example of the attribute. So I create an index based on the order that we want the attributes in. So here I choose the attack base as index 1, special attack base as index 2, defense base as index 3, and so on, so that we can choose the order in which the attribute bars appear in the report. Once that's ready, we can rename it as sort. Now we can rename the value column with kilogram and metric as value F. Now we can go back to the report and we can start creating the bar measure. So we can go to the description and copy the variable description, and then we can paste it to the new measure and we can call it bar measure tooltip. We can use the same measure for both the tooltip and the bar itself with slight modification. So the first thing to do is to change all the calculate selected values from description to the value f. Once that's ready, we can go to the Power Query and we can remove the duplicates from the attribute for a short while. We can copy the attribute values and paste them into the measure. So now we can reference the values for the measure filtering. Here we change all the descriptions to bar values, so the Pokémon from the bar values is the selected evolution. We can call the first variable height. Now we can create a division with the divide function. We can calculate the sum of the values from the table bar values, where the Pokémon equals the selected evolution 1. And the attribute equals height. Then we can create another division. So we divide the above calculation with the sum of the values, where we filter the whole table. So all the values, sum of all the values, where the type is the selected type. So we get the total values for the selected type. Then we divide that by the distinct count of Pokémons from all the Pokémons in the bar values table. Where the type again is the selected type. We have to remember to add the bar values attribute equals height for both calculations. So this way we get an average calculation for each type for the selected attribute, which is height. Now when that's ready, we can duplicate it and then we can paste it for each evolution like we did before. Here we just change the evolution accordingly. Now we can repeat the whole process for the second evolution. So we copy all three and change the contains function to the second evolution too. finally we can copy them once more for the third evolution tree. Now we can copy the height variable, we can paste it and duplicate it for the next attribute in the list, which is the catch rate. By changing the bar values attribute equals, filter criteria and the variable name. Then we replicate this process for all the attributes. Now when all the attribute variables are ready, we can go ahead and create our next variable, which is the unit. We can use the switch selected value and then the selected attribute. I just went and got the attributes again from the Power Query. Then I removed the filtering step from the query and applied. Now I select all the attributes with Alt and clicking, so it's easier to add the double quotes and commas. Next I'm adding the different variables we just created for the attributes. Here we calculate the bar length by multiplying the result of the attribute variables with a given number. So when we have different averages for different types for each attribute, we multiply that by a number that is set by the value that is the result of the attribute measure, attribute variable. This way we make sure that all the bars are correct length and not too long or too short. So here, if the height is equals or is more than 4, we call height times 1. Otherwise, if the height is more than 2 and less than 4, we call the height times 2, and else we call height times 3. Now we replicate this process for all the attributes. For the height and weight we use the same multiplication. Then for the catch rate, a different one, where if the catch rate is more than 2, we call catch rate times 1, otherwise we call catch rate times 2. Then the base friendship also is slightly different. We call the base friendship multiplied by 2. For the base experience, if the base experience is more than 1.5, we call base experience times 3, otherwise we call base experience times 4. Then for the hit points base, we call, if it's more than 2.5, then we multiply by 2, otherwise we multiply by 3. And for the rest of the attack base, defense base, special attack, special defense and speed base, we use the same multiplication, which is if it equals more than 1.5, we call it multiplied by 3, otherwise multiplied by 4. Now we have a set of correct length bars for each attribute. Next we can return the measure, and here we call if the Pokémon is filtered, Then we switch between the attribute values. So we insert a custom Unicode character as an icon identifier for the bar attribute. And then for the rep, we multiply the square by the times the unit variable has multiplied the average value for that attribute. So here rep square multiplied by the unit, so that say the unit returns 4 from the unit variable multiplication. So then the rep counts the square 4 times and returns 4 bars. So that's the length of the attribute bar. And finally we concatenate with the value to get a data label for the bar. Now we replicate this process for each attribute. We can search for custom Unicode characters from the Unicode Explorer. I have included a link into the description below. Finally, if the if condition is not met, so there is no Pokémon filtered, then we return blank as an else condition, so that the attribute bar remains blank. Next we can create the new slicer, place it into the attribute bar box. We can insert the attribute as the field value from the bar values table. Now we can reduce the columns to 1 and display the max rows shown 11, so all the attributes. And we can also disable the values from the callout values. Disable the fill and the border. Now we can insert our bar measure into the label field. As you can see, it returns an error that the sum DAX function cannot work with the text string. So we have to go back to Power Query, to the bar values table. Then we have to change the value column type to number from text. Change it to decimal number, replace, and now we can apply. And now the error disappears. We can also remove the background. And in the label field we can click the conditional format color, select field value and use our text color measure to conditionally color the bars. Now you can see the Unicode icons. Now we can apply the evolution from the filter table, so we can insert the evolution 1 is not blank and apply it. And you can see that the bars appear. And now we get a displacement for the first evolution, which is Frigibucks. We can increase the font from the label, make it bold, and finally we can do some final tuning for the Unicode characters, adding some spaces to make the bars align correctly. In Unicode Explorer there is a no break space Unicode character which allows us to insert more than one space next to each other in Power BI DAX measure. So once the adjustments are ready, we can now sort the attributes. So we can go back to Power Query, we can go to bar values table, add column. Then from the column from examples, we can select column from selection. When we have the attribute selected, now we can choose our sorting order. So here I'm choosing attack base as 1, special attack base 2, defense base 3, special defense base 4, and so on, to create the order in which the attributes appear. and rename the column as sort, and now applying. Once back in the report, we can go to the table view, we can go to our bar values table, we can select the attribute, and then from the top bar, sort by column, we can select the sort column. Now you can see the attributes appearing the order we just created. Now I'm going to the callout values, then I'm changing the font to DIN bold. Back in the bar measure, adding a space between the bar and the data label, and making some final adjustments to the Unicode icons. Now we can duplicate the attribute bar filters. First we duplicate it for the second evolution, so we can add the evolution 2 from the filter table. It's not blank, apply. Then we can do the same for the third evolution. It's not blank, and apply filter. Now we can rename the buttons as evolution 1, 2 and 3, and we can rename the bar filters as bar 1, 2 and 3. Now we can move the bars to the evolutions group. We can hide the second and the third bar and description, and then update the evolution 1 bookmark. And then we can do the same for evolution 2 and 3 bookmarks. Now the attribute bars are ready, and you can see they change based on the evolution. Next we can go to our bar measure, and we can duplicate the whole measure. Now we can create a new measure, and we can paste everything. Now we can duplicate the value variable. We can paste it as a new variable. We can name the variable attribute. Then the only thing we have to change is the selected value inside the calculate. So we will replace the value f with the attribute. Now we can duplicate this to all the evolutions, so that we are only displaying the attribute for the selected bar. Next we can go all the way down to the return. So in the return we create a CSS style block, then we create a value property, then we create a property for font size, and we input 20 pixels. We create a property for color, which is our dynamic text color measure. The font family has the same d-din, sans serif. Then we do an end style. And we call the function with value class equals text. We call our attribute variable. Now we do a line break with br, and then we can end the measure. Now we can go to Power Query. We can go to our filter table, and we can add a column filter. We add 1 dash as the filter value, and then we can apply. Next we go and create a new page. We can rename it bar tooltip. We can hide the page. Then we can change it to tooltip from the canvas settings. Now we can insert an HTML content visual to the page, fill the page with it. Now we can insert another HTML visual on top of it and resize it to the middle of the page. Now we can go to the background measure we created earlier and we can add another variable. We call the variable tooltip background and we can copy the values from the background to the tooltip background. The only modification we need to do is in the calculate filter condition. So we need to concatenate a TT after the selected type in order to display the tooltip image from our background table. We have to also change the else condition to blank instead of main. Now we can go to return and we can say if the filter is filtered from the filter table, then we call the image src tooltip background and we resize the background to fit the page. So the width is 310 pixels and the height is 230 pixels. Then we leave the background variable as an else condition and the background measure is ready. And we can add the bar measure tooltip to the middle HTML content visual. Now we can add the filter from filter table as a filter to the background tooltip image. Now the tooltip is ready. So when you hover over a bar, it will display the attribute, the Unicode character icon and the value. Now we can go to the main page and we can publish the report. Choose your workspace and publish. Once the loading is ready, we can open the report in Power BI Online and view the different Pokémon evolutions, attributes and types. If you watched this far, thanks a lot for watching and I hope you enjoyed and found something useful along the way. Feel free to ask anything in the comments below. I would love to answer your questions. You can find more information and the links from the description, plus the link to view and download the report. Thanks and see you next time.